discuss an interesting problem with the name Q. Firstly, let me tell you what you can expect from this particular video. We are going to discuss this particular problem. Then we would be discussing that what can be the approaches to solve this problem. After that, we would see the implementation of the approaches and the time and space complexity for the approach that we are implementing. Let's start and see what the problem statement says. Here you have given an array A of size n which contains only zeros and ones. We have to make array A sorted in the non-decreasing order, that is basically your ascending order. You can do the following operations as many times as you want. First is you can choose some indices, at least one. So your indices would be I, that would be between 1 to n minus 1, such that for all the chosen I, ai would be equals to 1 and ai plus 1 would be equals to 0. That means you have to choose the ith index. You can choose multiple i's between 1 to n minus 1, and the condition is that array at I should be equals to 1 and array at I plus 1 should be equals to 0. The next thing that you can do is you can swap element I with element I plus 1, right? So what you need to do is you need to print the minimum number of operations that you need to sort A in non-decreasing order. So here the constraints are that number of test cases would be between 1 to 10 raised to the power 3, n would be from 1 to 10 raised to the power 5. That is basically size of your array, and element can be only 0 or 1. Here the input format is, firstly, there would be a single integer t telling the number of test cases. Then first line of each test case would be a single integer n telling how many numbers would be there in the array. And second line of every test case would contains n integers, that would be your n elements of the array. Then here it is given that sum of n numbers among all the test cases would never exceed 2 into 10 raised to the power 5. Now output format is that for each test case you would need to print a single line which would be consisting the minimum number of operations that you needed to sort array A in non-decreasing order. Here a sample input and sample output is given to you. Let's just see over this sample input that how we can solve this particular problem. Here the problem statement says you have given an array of size n which is only having 0 and 1. So let's just understand this particular problem statement through the help of an example. Let's take this particular example where you are having 5 elements in the array, and elements are 1, 0, 1, 1 and 0, right? Here this problem statement says you would be having an array of size n. So yes, we have an array A of size n which is equals to 5, which is containing only zeros and ones. So yes, our array is containing only zeros and ones. Next is you have to make array A sorted in non-decreasing order. That means our resultant array should be something like this: 0, 0, 1, 1, 1. This is the sorted array in non-decreasing order, right? Next thing is you can do following operations as many times as you want. What these operations are? First is you can choose some indices, at least one index, I, between I equals to 1 to n minus 1, such that all the chosen i's would be equals to, such that a of I would be equals to 1 and a of I plus 1 would be equals to 0. So let's just find out which all the indexes are there in which your ith index would be equals to 1 and your I plus 1th index element would be equals to 0. So here your ith index is 1 and I plus 1th index is 0. We can't choose this as our I, right? Because its I plus 1 is not 0. So we can't choose this one, right? So this is not valid to choose. Now we can choose this as I and this as I plus 1, right? Because here I is 0, I is 1 and I plus 1 is 0, right? So right now we have chosen two indices. This can be our I and this would be our I plus 1. This can be our I and this can be I plus 1. We can't choose this as I just because its I plus 1 is not 0, right? So this is not a valid case. Now, what is the next thing that we can do? What can be the next step? So it would be you can swap A of I with A of I plus 1. So that means we can just swap this 0 and 1 as well as we can swap this 0 and 1. Let's just see what would be a resultant array after this swap. So it would be your 0 and 1 would be swapped. So it would be 0 comma 1. Then after this 1, then again this 1 and 0 would be swapped and it would look like this 0 and 1, right? So here you can see by doing this step, we are going somehow towards our solution. How we are saying this? So see, the zeroth element should be a 0 as per a resultant, right? And we have taken our 0 at its right place. Now, as per our resultant, last element should be a 1 and we have the last element as 1. So, slowly we are moving forward towards our solution, right? And this was our first step. This was our first step in which we have chosen some i's and after that we have swapped them with I plus 1, right? Now it says that you need to print the minimum number of operations that you would be needing to sort the array in non-descending order. So, as we have done this first step, similarly, we would need to do this step many number of times to reach a resultant array like this, right? So here, let's see how many times we will need to do this step. So let's try to do this step again. So our criteria was that I should be equals to 1 and I plus 1, A of I should be equals to 1 and A of I plus 1 should be equals to a 0, right? So here we can see that here your I is equals to 1 and here your I plus 1 is equals to 0. We don't have any other such index, right? So here what we will do, we will swap them and your resultant array after your the second step would be equals to 0, 1, 0, 1, right? Still our array is not sorted. So again, we would choose our ith index and I plus 1th index. So this is our ith index, which is 1, and I plus 1th index is our 0. What we will do? We will just swap them. And after swapping, this would be our third step. After third step, our resultant array would be 0, 0, 1, 1, and 1. So you can see this array is sorted, right? This is the array that we wanted as our resultant array, right? This would be our final array. So you can see how many steps we have taken. First step in which we have chosen these two indexes as our ith index, this one and this one. After this, in second step, we have chosen this as our ith index. And in third step, we have chosen this as our ith index, right? So in three steps, we have done this. Now let's check the answer. So we have taken this particular case. So answer for this case is last one, that is 3. So we are done, right? This is working fine. Now, one thing to notice here is that you can't solve this problem using just the two pointers approach as you do to sort a normal 0 and 1's array. Why? Just because here It is given in the question that what are the conditions or what are the steps that you need to follow. So first is that you can only choose the ith index where I plus 1 is equals to 0 and you can swap them. This means you can't swap any random elements. You just have to swap only the adjacent elements. That's why you can't just follow the two pointers approach that we generally do to sort a zeros and ones array, right? So here you will need to write a loop to traverse all the elements and find your ith and I plus 1th index and then swap them, right? Then we will see how many times you would need that loop. So as many times you will need to loop over your elements, that would be your number of steps. Cool? So let's try this particular approach on this second case also, in which there are four elements 0, 1, 1, 0. So if your elements are 4, 0, 1, 1 and 0. In this particular case, as we know, our first step would be to choose I, where a of I should be equals to 1 and a of I plus 1 should be equals to 0. So here, for this one, we can't choose this one as our I, this index as our I, right? Just because its next index is not a 0. So here your indexes are 0, 1, 2, 3. So here we can choose this index as our I because its next is 0. So here this would be our I and this is your I plus 1. What we are going to do, we will just swap them and this would be our first step. After this first step, our resultant array would be 0, 1, 0, 1. Now again, we are going to see that which all the I's would satisfy our condition. So here we can choose this one as our ith number. So this is your 0, 1, 2, 3. This index can be our ith index because its next I plus 1 is a 0, right? So here we will just swap them. And after our second step, your resultant array would be 0, 0, 1, 1. And this is a sorted array that we needed. So how many steps we needed? 1 and 2. So total 2 steps are needed. Let's just check the answer. So here you can see for this particular case, your sample output is 2. So our approach is working fine, right? Now let's just see how we can code this particular approach. Here, let's try to first write down the steps that we are following to solve this problem. Here your first step would be to choose all i's, right? All i's means where your a of I is equals to 1 and your a of I plus 1 would be equals to 0. Then your second step is swap all chosen a of i's with a of I plus 1s, right? This would be our first step according to the question that is given. This would be our first operation according to the question, right? So here what you need to do is after this step, after this first operation, your third step gonna be increase number of operations that you have done to make this array sorted. Then again, after increasing the number of operations, you are gonna do the same thing You will choose the i's where a of I would be equals to 1 and a of I plus 1 would be equals to 0. Then again you would swap them and increase your number of operations, right? It would keep going on until your array would become sorted. Now the thing is how you will find out that where your array is already sorted. So in the case where you are unable to choose any I, where I is equals to 1 and I plus 1 is equals to 0, in that case we can say your array is sorted, because in the sorted array there won't be any case of array of I equals to 1 and I plus 1 is equals to 0, right? So when we would be choosing our i's, we can just track that if in any operation we are unable to find any ith element which is equals to 1, where I plus 1th element would be equals to 0, then we can say our array is already sorted and we can just stop here, right? So let's just see how we can implement this particular approach. Here, let n is equals to 5, that you are gonna have 5 elements in the array, and let your array is equals to, let's take it from one of your sample test cases, that is 1 0 1 1 and 0. After this, we are gonna see that how many operations you would need to sort this array. So let result is equals to sorting array, in which we are passing our n and the array. At the end, let's just print our result. Now let's just implement this particular function, which is sorting array. So function sorting array, in which we are having the variable n as well as our array. So here initially we haven't done any operation. So let's say the number of operations are equals to 0. And after that, we are just going to traverse through the array to find our ith elements. So let's say let I is equals to 0, I is smaller than n, and I plus plus. And here we will see if we are able to find any ith element which is equals to 1 and any I plus 1th element which is equals to 0. If that's the case, then we can just swap them. So we can just say that array of 5 and array of I plus 1 should be swapped as array of I plus 1 with array of I with array of I. So here your swapping would be done, that array of I plus 1 would be assigned to array of I, and to array of I plus 1 your earlier value of array of I would be assigned. So by this your swapping would happen. Now after swapping, as we have already considered I and I plus 1, we don't need to consider them again, right? But here your I plus plus would again consider your I plus 1 to check if it is 1 or 0, right? So to ignore that, what we can do, we can increase the value of I here. That if we have already considered your I plus 1 in this condition, then you don't need to consider it again, right? This was our first operation, right? So at the end of your first operation, we can just increase the value of number of operations as operation plus plus, right? Now the point is you would need to do this operation multiple number of times, right? So we can put it inside a loop, and where your loop should stop. So your loop should stop when your array is already sorted. Otherwise, loop should go on. Let's take a variable sorted, which is saying that if your array is sorted, and initially let's take its value as false. Now we can just put a loop here that until your sorted is not equals to true, in that case we need to do some operations. So if your array is not sorted, then we would be doing the operations, right? Now what we can do to check if our array is already sorted or not. So before doing any step, we can just mark this sorted as true. For now we are assuming that your array is already sorted, but as soon as you will do some kind of operation here, what we will do, we will mark this sorted as false, that your array was not sorted, right? So after this, when it would go again to check here that if your array is sorted, so if your array was not sorted, sorted would be set to false, and this condition would become true, that sorted is not equals to true, and we will keep going on. But when your array would be actually sorted, so initially your variable is sorted equals to true, if you will not go in any step, right, to swap any of the elements, your sorted variable would never change to false, and that means we will end the loop with your sorted variable as true, right? And here, when the loop would check again inside this while condition, that is sorted not equals to true, that would become false in case of sorted array, because sorted equals to true would remain sorted without any swap happen, right? And your this particular loop would break, and at the end we can just return your operations, the number of operations that are happened. Now there is one more thing, that we are increasing your operations every time, right? But you should not increment your operations when your array is already sorted, right? So here we can just put a check that if sorted is equals to false, in that case only we have done some operation, otherwise we haven't done any operation. So we can just say in that case only you are supposed to do operations plus plus, right? So here let me go through this particular program again. Initially your operations are 0, your array sorted is equals to false, right? Then we are checking that we will run this while loop only when your sorted is equals to false, that means sorted is not equals to true. Then we are putting your sorted equals to true for the start, and we are traversing through your array. Now if there comes this condition that ith element is 1 and I plus 1th element is 0, then we will swap them. As we have swapped them, so we have already considered I and I plus 1th element. We don't need to consider the I plus 1th element again. So we will increase our I here, that you don't need to consider the I plus 1th element. In the next loop, you can just consider I plus 2th element, right? And here we have marked our sorted as false. So this would be your first operation. At the end we can check if your sorted is equals to false, that means your array was not sorted, you have done some swap operation. In that case we can increase our operations. So this loop would keep going on until there would be an operation in which you are not making any swaps. So in that case your value of sorted would remain true, and here when it would check that okay sorted is equals to true, then while loop would break, and at the end we are just returning the number of operations. One thing to care is that we would increase our operations only when array was not sorted, right? If your array is already sorted, then you don't need to increment your operations. Now let's just try to run this particular code, that what should be the answer. So here you can see your answer is 3, which is the correct one as we have seen earlier. Now let's try on one other case also, that when you are having only 3 elements, so firstly this one should go at this position and after that at the last position. So it should take 2 steps. Let's try to run it. So here you can see your answer is 2. So it is giving us the correct answer. Code is working fine. Now let's talk about the time complexity of this particular problem. So here you can see in this particular loop we are traversing through all the elements. So time complexity of this loop would be big O of n. Now, in this loop, in this while loop, we are traversing through your whole array. But how many times? Number of operations time. So if you would take the worst case as this one, that one was at the starting position, then it was swapped with first element in the first operation, then with the second element in the second operation, right? So here you have seen that for a array of size n, it would be taking n minus 1 steps to make this one reach till the end. So that's why we can say that how many operations you would need to perform in the worst case. In worst case, this loop would go on for big O of n minus 1 times, right? So as you can see, for n minus 1 times, this inner loop is running n times. So the total time complexity of this outer while loop would be n minus 1 into n, which is basically big O of n square n raised to the power 2. So I hope this particular approach is clear to you and the implementation also, that how we are solving this problem, and you would be able to solve the similar problems in future. Thank you. Take care.